In 4.2, we are now getting our first look at logarithms. Now, some of y'all may have seen these before. Odds are you probably haven't. But logarithmic functions, they are the inverse of the exponential. So everything in math has an inverse. And, kind of going back to the calculator, you see the log, ln, that's the common logarithm. Its base is 10. The natural logarithm, its base is e. So they are inverses. So the natural logarithm is the inverse of the e exponential function. The common logarithm is the inverse of the 10 to the x exponential function. Now, we do other bases. There's 2 to the x, 3 to the x. There's all kinds. We will look at other ways to handle those at another time. But for right now, on your calculator, as far as that goes, you're defaulted at base 10 for the common logarithm, base e for the natural logarithm. There are two types of logarithms, as I showed on the calculator. You've got the common logarithm, and that is common log, some base of x equals y, and the natural log. We don't normally write the base, but it is e. So those are your differences, and the common log, the base varies. The natural log, the base is always e. And again, your calculator is defaulted to base 10. So here is your basic definition. This is kind of a transformation of sorts from a logarithm to an exponential and then vice versa. And this allows us to rewrite these expressions in order to evaluate and to solve them. Now, the way this is read right here is log base a of x equals y. A is your base, as you can see in the transformation. A is your base. Y is the exponent. Y is the exponent. X is the number or the result or whatever. But I just say that if I have 2 cubed, that's 8. So 8 is my result or my number, and right here. Now, you've got your exponential form, your logarithmic form. The answer when you take a logarithm of a number is an exponent. And in a common logarithm, the log logarithm, if there is no subscript given, then we assume the base is 10. And what I mean by subscript is down here. That's your subscript. Okay? So let's look at the two forms of going from an exponential form to a logarithm form and vice versa. So in this case, 10 to the 4th power is 10,000. So as a logarithm, the logarithm of 10,000 is 4. And on my calculator, if you do the log of 10,000, you'll get 4. And that means with a base of 10, the power of 10 is 4. That gives me 10,000. So if I have 5 cubed is 125, I can say log base 5 of 125 is 3. 6 squared is 36. Log base 6 of 36 is 2. So just remember, in a logarithm, the exponent is always over here. The base is a subscript. The number goes in this position. Okay? This is not 6 to the 36th power. Don't do that. 10 to the x is 150. So in this case, I don't know my exponent. But if I take log, and since my base is 10, I don't have to write it. I can solve for x now because I can put log 150 into my calculator because my calculator is defaulted to base 10, and I get 2.18 roughly. And that's pretty much how you solve them. Okay, they get a little more difficult than that, but for the most part, you change forms and you are going to enter something into your calculator. Same thing with this one. 10 to the x is 1300. So log 1300 equals x, because see, x is my exponent. I'm just going from this format to this format. Pretty much, you know, don't overthink it. Just put y where y goes, x where x goes, a where a goes, and move on. Okay? In time, the understanding will come. Too many times we try to figure everything out why it's all doing this. Don't do that. Just do what I say. And in time, you will get it. Okay? So don't worry about it right now. We got plenty of time on this. So, in this case, my exponent is 3.11. Okay? So what I'm saying is 10 to the 3.11 power should give me 1300. So if I do 10 y to the x 3.11, I get 12,088, and because we rounded, it's going to not be exact. So that's the difference. When you start rounding exponents, things do change a little. Okay? So now I'm going back the other direction. So I start with the logarithm. Now I want to change it to the exponential form. So log, we don't write the base. We assume it's 10. Of 100 is 2 because 10 squared is 100. So my base is 10. 2 is my exponent. 100 is my number. Here, log of 1,000 is 3. 10 cubed is 1,000. Then I get into other bases. It's okay. Just do the base to the exponent equals the number. 4 squared is 16. 3 squared, to the negative 2 is 1 over 9. Negative exponents just imply, if you don't remember those, 3 to the negative 2 is 1 over 3 squared, and that's how we get 1/9. And then lastly, log of 2x equals 1.4. So again, my base is 10, my exponent is 1.4, and that's equal to 2x. So I can solve for x and find out what this is by taking 10 to the 1.4 power, and I get 25.12 equals 2x. Divide both sides by 2. And x is 12.56. Okay? So that's pretty much the transformation. Sorry, left my water in the other room. I'm starting to get dry mouth. So the key is, again, to refer to these two forms, know what you start with, and just transform it into the other format, if that's what you're asked to do. Now, the next item is the natural logarithm, and I kind of, as I was editing these, forgot to bump that natural logarithm up to the next page, but that's it right here. And the only difference is we use the ln, not in, that's ln. Base is e. Now, we don't write e as the base or the subscript, but you can if you want to. So the setup is exactly the same outside of the base. That's the only difference. They work exactly the same way. Logarithms, exponentials, different bases. So the exponential form of a natural logarithm is e to a power gives me a number. As a logarithm, log of the number equals the power. Okay? So again, log of the number equals the exponent. If you're not sure, do it on your calculator. And in this one, I got to kind of do things backwards, but it's okay. 4.48 natural log, 1.4996, which is 1.5. Okay. E to the 2.3 is 10. That means natural log of 10 equals 2.3. Again, the number on the right side of the equal sign is your exponent. So if I have e to the x is 25, I can say natural log 25 equals x. I can punch this into my calculator, and anytime I do a logarithm, I am getting an exponent So this is 3.22 would be my power of E that gives me 25. We can also go the other direction. We can go from a natural log to the exponential form. Again, number, exponent, E is my base. So I go E to my exponent of 2 equals the number. Natural log of 20 is 3. E cubed is 20. Natural log 0.5 is negative 0.69. So E to the negative 0.69 is 0.5. Here I have an unknown. X, natural log of X is 2.4. So E to the 2.4 is X. So we did E last time. So just know how to access your E button, your E function. And it's like 11.02 equals my X. Natural log of X is negative 1.6. So E to the negative 1.6 is X. Find out what E to the negative 1.6 is, and I get 0.2. Okay, so these are the basic, solving or basic logarithms you can solve for. But still, even when you get to the more difficult ones, you just have to remember to, change from one form to the other. So here are your steps to solving a logarithm. First thing you want is you want to have the logarithm by itself. So the log of whatever's inside the parentheses. Okay, whether it's x, 2x, x plus 1, whatever by itself. Rewrite as an exponential equation. Solve for the unknown. So let's look at one. We've already solved, the basic one-step ones. Now let's look at one that might have a few more steps. So here, log of 4x minus 7 is 2. My base is 10 because it's not written. So what I'm going to do is I'm going to rewrite as an exponential equation. So 10 squared equals 4x minus 7. Base to the exponent equals the number, and then I'm going to solve from there. 100 is 4x minus 7. Add 7. Divide by 4. Sorry about that. I'm running out of room here. And 26.75 is X. For this one here, my base is 3, exponent 2.5, and that's my number. So again, my log of the number is isolated. Rewrite as an exponential equation. So 3 to the 2.5 power is 2x. I've got to figure out what is 3 to the 2.5 power. I get 15.6 roughly. Divide by 2. So x is 7.8. Nothing changes for the natural log. The only difference is my base. So if I have the natural log, ln x is 3.2. E to the 3.2 is x. So I type in E to the 3.2 and I get 24.5. Now, these are more higher ordered operations, logarithms and exponentials, but when it comes to solving, if you understand how to undo the logarithm, how to undo the exponential, there were usually 1 or 2 steps after that. Okay, now we will look at solving different types of exponentials in the future, but right now we can go ahead and solve exponential equations. You want to always isolate the base to the exponent, change to a logarithm, solve. So in this case, I have e to the 2x is 5. I change to a logarithm, so the natural log of 5 is 2x. Remember, a logarithm is equal to an exponent. So that's the setup. Now punch into my calculator natural log of 5, and I get 1.61 divided by 2, and x is about 0.81. Okay. For this particular one, I need to isolate the base to the exponent, and I've got this 3 sitting here. So I can divide by 3 since I'm not affecting my base. I'm getting rid of multiplication right here. So then e to the x plus 1 is 3.33. Now I can change to a logarithm. So exponent goes over here, log of 3.33. Put that into my calculator. I get 1.2. And then, don't forget your basic solving steps. Subtract 1 to get x is 0.2. Okay, so that's changing from one form to the other, which the extra step beyond that is to solve when you do have an unknown. We can also find exact value of logarithms without using a calculator. We'll figure out how to do this using a calculator. But, if I think about, okay, what is the exact value? In other words, what is my exponent? 2 to what power equals 16? That's kind of what I am asking here. 2 to what power is 16? If you're not sure, try different powers, but the answer would be 4. 2 to the 4th is 16. Log base 3 of 1 over 27 is what power? So if I think about the exponential form, 3 to what power is 1 over 27? Thinking about what we discussed earlier with some of the transformations we made, when we have a 1 over value, it becomes a negative exponent. So since 3 cubed is 27, 3 to the negative 3 would be 1 over 27. So the answer to part B is negative 3. Okay, it's all I'm looking for the exponent here. And, like I said, in probably, down the road, there's a way to do these on your calculator. But for right now, since they're nice whole numbers, integers, you can figure these out without a calculator. Logarithms also have domain issues. They got issues, man. Just issues all over the place. For example, if I told you to find the log of negative 10, I get an error. You cannot take the logarithm of a negative number, or 0 for that matter. So the domain for any number you put into your calculator to take the logarithm of, it must be bigger than 0. So therefore, if I have this function, where I want to graph or substitute values in for x, I do have restrictions. Doesn't matter what the base is. All I know is x plus 3 must be greater than 0. So whatever I put in here for x has to be bigger than negative 3. Similarly, since this is log of x minus 4, x minus 4, this expression here, again, must be bigger than 0. So in order to satisfy that, x must be greater than 4. So these are my domains. And you can certainly, if you're wanting to do your domain, it would be negative 3 to infinity, and this one would be 4 to infinity. Lastly, I know it's been a long one, we want to look at graphing. Okay, and with the exponential functions, we had a horizontal asymptote, and the graph had a curve. Logarithms also have a curve, and they have a vertical asymptote. So again, remember, these are inverses of exponentials. The shapes are fairly similar. They're just kind of shifted around a little bit. And the reality is, for log x, well, you have an error, so that gives us our vertical asymptote, because x's, we have restrictions on the domain, which is how we get vertical asymptotes. And then as x gets big, y grows very slowly. That's why it kind of levels off like this. So to graph these, we're going to graph them by transformations, just like we did the exponentials, but it's going to be transformations involving the shape of the logarithm. So if you find the domain, then that can determine the equation of the vertical asymptote, which can help you find the x-intercept and sketch the graph. Or you can just shift it. Okay, so there's kind of, two ways to do it. You could shift the x-intercept, which is all going to come from here anyway. Or you can find some points. All right, so if I'm doing log x minus 3, so my domain is x is greater than 3. So I come here to 3, draw my vertical asymptote, and my x-intercept is at x is 4, and then I sketch it. The other way is just to shift log x right 3 units. Horizontal shift because it's in parentheses. And that's what I did. I shifted my vertical asymptote 1, 2, 3, shifted my x-intercept 1, 2, 3. So really, I just took this shape right here. There's my x-intercept, and shifted it right 3 units. So don't forget, this line here borders the y-axis. It looks like it stops, but it doesn't. So with this natural logarithm, if you want to find your domain, well, x plus 2 greater than 0, so x is greater than negative 2, which on my table here is my vertical asymptote. The x-intercept is 1 point greater, and I sketch it. Shifting, if I wanted to do it by shifting, I would shift left 2 units. It's opposite the sign. Okay. We will do more practice on these. So if you don't quite have it right now, it's okay. We'll do more of them. But I don't want to spend all day and make you fall asleep watching these videos.